Good morning, students. Students, let's start our chapter number 2 with the topic what? Some applications of flotation. Students, third point of this application, flotation of ice on water. Students, a piece of ice, okay, that floats on water with its how much part, students? It's 9 by 10th part inside the water, and only how much? Only 1/10 part of it is outside the water. What is the reason behind that, student? So students, the reason behind that is, first of all, that the density of ice is 0.9 gram per cubic centimeter, while the density of water is how much? 1 gram per cubic centimeter. Hence, students, the weight of water is displaced by 9 by 10th part of ice immersed inside what? Water. That becomes equal to the weight of the ice piece. Now, students, we will talk about the next point, submarine. Students, a submarine can be made to drive or to rise to the surface of water as and when it is desired. What is the reason behind that? The reason is that a submarine is a watertight boat, okay, which can travel underwater like ship. And students, this is the submarine as you are seeing here. It is provided with water tanks. First of all, students, it is provided with a water tank. To make the submarine drive, what is happened? Water tanks are filled with water. I will show you in this diagram. These here you are seeing the water tanks. Okay, here when the submarine is made to drive, what happens? The tanks are filled with water. Why? So that the average density of the submarine becomes greater than the density of seawater. And what happens? It sinks. Now, to make the submarine rise to the surface, what is done? The tanks are emptied. What happens from that? The average density of the submarine less than the density of seawater. So the submarine rises up to the surface of water. Now, students, we will study something about icebergs. Students, what are first of all called icebergs? You see that very huge and large pieces of ice floating on seawater, those are called icebergs, and they are very dangerous for ships. Why? Because the density of ice is less than the density of seawater. What is the density? The density of ice is 0.9 per cubic centimeter, and the density of seawater is 1.02 gram per cubic centimeter. So, the icebergs floats in seawater with its large portion submerged inside the water. Only a little portion of it is above the surface of water. This. Okay. Are you seeing in the diagram? Like this. Now, a ship can collide with the invisible part of icebergs under the surface of water. Hence, they are very dangerous for the ships. Now, what about the whales? The whales can sink or rise at their will. Whales are sea animals, as you know that, and they are having the special organ in their body. What is that called? Swim bladder. Students, to come to the surface of water, they fill the bladder with air. By this, the average density of the whale decreases and it rises to the surface. Now, what to drive? To drive into the sea, they empty this bladder. And what happens due to this? They increase the average density and it goes down. What about the balloons? Students, a hydrogen or a helium filled balloon, it rises up in the air. As you are seeing when you are going to market, you are seeing many balloon sellers are there, and they are why their balloons are rising up in the sky, uh, because they are filled with hydrogen or helium. So the reason is that the density of these gases is less than the density of air. That is why the beyond force experienced by the balloon due to air, it becomes greater than the weight of the balloon. That is why balloon rises up under this influence of the net upward force. So students, there are some solved examples. So let's see these examples. A block of glass is 30 centimeter long, 25 centimeter wide, and has a thickness of 2 centimeter. Now you have to find its density if the mass is 7.5 kilogram. Student, first of all, find out the volume of this glass block. Okay, and which formula we will use? L into B into H, or L into B into thickness. Here thickness is given. Okay, so when you will find its volume, what will be the solution coming? 1500 centimeter cube. So in the question given mass of the block, that means 7.5 kg is given. You have to convert this into grams. Okay, now you can easily take out the density. Why? By which formula? Density is equals to mass upon volume. You know the mass, you know the volume. Okay, you can easily get the answer. Now comes to the next point. Next solution. The piece of iron of volume, how much? 30 centimeter cube, has a mass of 234 gram. You have to find the density of iron. What is the mass given here, students? 234 gram. What is the volume given here? 30 centimeter cube. You can find out the density by the formula mass upon volume. Okay. Now when you will solve this, the answer will be coming 7.8 gram per cubic centimeter. Now the next question, third. The mass of 10 centimeter cube of silver is how much, students? Silver is 103 gram. You have to find out here the two questions. First of all, the density of silver in kilogram per meter cube and relative density of silver. State the assumption made in part B. Okay. Now, what is the mass given in your question? 103 gram. And what is the volume given here? 10 centimeter cube. You can find out the density by the formula mass upon volume. Okay, when you will get the formula, the answer you will get it in gram per cubic centimeter. But here it is saying that you have to find out the density in kilogram per cubic meter. So you have to convert it into kilogram per meter cubic per cubic meter. So when you will convert it, you have to multiply the answer with 1000. Now you have to find out the relative density also. So what is the formula you will use? The density of silver, the substance, divided by the density of water. So you know that you have got the density of silver divided by the density of water. You students, you will get the answer of 10.3, and here no unit will be used. Okay, you know that the relative density is not having any unit, it is having only the number. The assumption is what? The density of water is what? 1000 kilogram per cubic meter. Now students, a piece of iron when immersed in water taken in a Eureka can displaces 25 milliliter of water. Its mass is 195 gram. You have to find the density of iron in kilogram per cubic meter. Now what you have to do here, students? The mass of iron piece given that 195 gram, you have to convert it into kilogram. Then volume of the iron piece, volume of water displaced is equals to how much? 25 centimeter, which is given in your book, in your question. That okay, that means 25 multiplied by 10 raised to power minus 6 meter cube. Now what is the density of iron here? By the formula mass upon volume, and you will get the answer. Okay, now students, let's see our question number 5th. The block of silver displaces 200 milliliter of water in a measuring cylinder. If the density of silver is 10300 kilogram per cubic meter, find the mass of block. What is the solution, students? Density of silver is given, so you have to volume is also given. So students, you have to find out the density. Density is equals to what? Mass upon volume. And you know, students, that mass of the mass of the block is given what? 200 into 10 raised to power minus 6 meter cube. Sorry, mass of volume you have to find out. So what will be the formula making? Volume into density. So 200 into 10 raised to power minus 6 meter cube multiply by 10,300 kilogram per meter per cubic meter. So when you will solve this, students, you will get the answer 2.06 kg. So for today, up till here, we will continue in the next video. Thank you.